We spend hours every day talking to our devices. We ask them to draft our emails, organize our finances, and even provide emotional support. But the closer we integrate this technology into our routines, the less we actually see of how it works. This data reveals a strange paradox. Right now, half of the population in the US actively uses AI, but 60% of people say they distrust the companies building it. That skepticism comes down to the black box problem. When you ask an AI a complex question, it produces a polished answer, but it completely conceals the math and the reasoning it used to get there. If we are going to rely on these systems, we can't just judge the final output. We need to be able to look inside the box and read the machine's mind. Researchers at Anthropic recently discovered that AI models have organically developed their own internal workspace to process information. They call it J-space. It functions a lot like a human's inner monologue. When an AI calculates a multi-step problem, it manipulates those ideas silently in this hidden layer without ever verbalizing them. Simple facts, like the capital of France, bypass this space entirely. The network only routes information through J-space when it needs to engage in deep deliberation and creative thought. Mapping this neural structure allows researchers to observe a model's internal deliberation before it ever begins to output text. This visibility solves a massive problem for AI safety. Models can detect when they are being tested, and they are capable of outputting perfectly polite text while secretly harboring malicious goals or fabricating data. To counter this, scientists developed a technique called a Jacobian lens. By pointing this tool at the J-space layer, they can identify a pulse of active deception while the model is still formulating its answer. We know this space is the engine for complex logic because of what happens when you turn it off. If you completely disable J-space, the AI maintains its fluent speech, but it loses the ability to solve multi-step problems. This shifts the focus of AI safety. We no longer have to rely on policing the text the machine generates. We can interrogate the silent intentions it hides. The systems are also using this metacognition to examine their own software. They are actively identifying the flaws in their own architecture. This is a process called loop engineering. When an AI fails a task, it reads its own execution trace, writes a targeted fix for its code, and verifies that the new pathway works, all without human input. When researchers applied these self-correcting loops to lightweight models, their performance scores on standardized benchmarks jumped by as much as 60%. These self-tuning loops allow a 9 billion parameter model to iterate on its own instructions until its output matches the quality of systems 10 times larger. The models are even applying this self-analysis to optimize how they interact with physical hardware. Recently, an AI analyzed its computational bottlenecks and wrote a radically new GPU kernel. Instead of using the 14 separate data launches common in traditional development, it consolidated the workload into a single cooperative launch. The resulting code ran over 18 times faster than the highly optimized baselines built by humans. By writing the exact low-level instructions needed to run itself faster, the AI has initiated a recursive loop of improvement that changes the economics of the entire industry. To recoup massive investments in training facilities, the largest AI labs currently operate with approximately 90% gross margins on cloud inference, the computing cost of actually running the models for users. But capable open-weights models are hitting the market with text performance that rival those top labs. An open model like GLM 5.2 costs just $4.40 per million tokens, nearly 1/5 the price of proprietary equivalents. For developers building applications, the switching costs between these providers are practically zero. Swapping to the cheaper model takes minutes. When nearly identical performance is available at 1/5 the price, the high profit margins sustained by proprietary labs face a permanent downward pressure. The final step in making this technology accessible is cutting the tether to the cloud. We no longer need remote server farms to run these models. Hardware companies are releasing pocket-sized developer kits packed with 128 gigabytes of unified memory. These bring enterprise-level memory pools directly to a consumer desktop. Instead of relying purely on energy-hungry graphics processors, these machines use integrated neural processing units. That allows a 20 billion parameter model to run continuously while drawing just 35 watts of power. Running an AI locally guarantees total data privacy and eliminates monthly subscription fees. The control is migrating away from the provider and directly back to the user. These cheap, local, self-optimizing models have transitioned away from passive text generation. Today, they actively execute complex digital labor. The Remote Labor Index tracks how well AI can complete real-world freelance projects like 3D modeling and data analysis without human intervention. In less than a year, the success rate for these models jumped from a marginal 2.5% to over 16%. Rather than manually prompting a static tool, users can now delegate multi-hour workflows to agents that plan, execute, and course-correct their own code. A moment of wonder. By illuminating its own silent thoughts, rewriting its internal flaws, and running entirely on our own desks, AI is stepping out of the black box. It has evolved into a transparent, indispensable partner.